Hi, my name is Remus Rusanu. My greatest claim of fame is indeed I have a huge amount of reputation on Stack Overflow. But by day, I'm a developer. And I work at UiPath now. Been doing that for the past 2 years. And I give boring presentations. So without further ado, I'm going to go a little bit 10, 15 minutes go over what is our product, does it do, because almost nobody does, and this is the spiel I give on interviews to relax the candidates before the bloodbath. So imagine a universal DOM on the desktop. So if you're familiar with the JS DOM, right, it gives you access to the various controls and the various widgets on the surface or the browser surface. We want to present developers with a universal DOM who covers the whole desktop, including Java applications, native applications, managed applications, the browser, be it Chrome, Edge, Firefox. And we give application developers, the RPA developers, right, the means to control these other applications. This is what the RPA automation is. We take other applications and we control them, whether they're willingly cooperating or sometimes unwillingly. So for this, we leverage a bunch of technologies, UI automation, we go by the GDI path. So different technologies used in different contexts for automating different targets. And basically, for instance, with a desktop application, we can get text of a widget which is found using GDI. So class, name, foo, with attributes bar, the search child, and get the text, right? Or we click a button on a web page. This will be via the actual DOM. We inject in the browser, and we call the DOM click. Java applications, there is Java automation API, and computer vision is one size fits all because it goes visually, so it finds the button because it can recognize the button on the screen. So that goes well with, especially with things which don't work with anything else, and also when we're actually automating a target which is behind some screen we cannot traverse, like Citrix, for instance, right? Citrix runs on the back end, we have to automate it on the front end. Now that we also have Citrix automation on the back end, but that's a different story, right? And that's what our robots do. The robot uses the driver component, which does all this magic, to automate various applications. A UiPath process is basically how we set up these fundamental steps of automating. Like in order to write an application, you take this, find this button here, take the text. Well, let's say I said find this text box here the first time. Take the text. And then open another application, set focus to it, locate another text box, and type the text. So you basically copy the text from an application into another application, which the user, the human operator previously was doing, opening that application, control copy, go to the other application, control paste, right? So we serialize these steps into a process. We use Windows Workflow Foundation as the language through which we represent these processes. And the automation the core UI automation is just it's our bread and butter, it's our secret sauce, but it's just one aspect because we can automate a lot of other aspects. We can do REST calls, we can do database calls, we can do a lot of Office automation, the Office suites from Microsoft, what we mean by that, Excel, Word, and so on. Very commonly used in the enterprise. And we basically, when you deploy a UiPath process, it models a business process which previously was done by a human. Like, what is the process of paying an invoice? Well, the invoice shows up in my inbox. It's a PDF. I look at it. I see the contract number. I go to my contracting software. I find the contract, see that it's valid, so on and so forth. So I developed a process which reacts to the inbox, opens the Outlook inbox, opens the attachment, does OCR and computer vision on the PDF, extracts the element, opens the accounting applications, finds the contract, so on and so forth. But all this is automated. Orchestrator. So when you successfully deploy these UiPath processes and you automated your invoice payment, other departments will come and say, hey, I want to automate too. So soon you'll have 10 robots, and then you'll have 100 robots, and soon you'll have 10,000 robots deployed. So you want to know what's it doing. You want to know which is online. You want to know which is offline. What processes have they run? How do you configure them, how you manage them, how do you administer, monitor, and so on and so forth. So this is the orchestrator, which is a website. You can call it a website. It's a web app. And this is the administrative application for managing a large park of robots. We also have a community edition. You can go online to UiPath, cloud.uipath.com, and you can have your own little piece of orchestrator. Activities are the rich ecosystem using Windows Workflow Foundation. This is an open platform. Anybody can create activities for Windows Workflow Foundation. And we have a rich set we ship out of the box. We have a rich set of open source activities. And we have contributions from third parties and developers who do this either for monetization or because they want to show some problems. So activities are fundamental pieces of fundamental units of resolving a problem. They can interact with Excel, they can export something as a CSV, they can do intelligent OCR. So we have a very rich investment into whole packages of activities. I try to list them, some which just showed up when I opened my developer environment. Speaking of, this is our developer environment, the UiPath Studio. And UiPath Studio, think of it as Visual Studio. That's what the name comes from, right? And it's the software used to create RPA automation. It's a design surface on which you drag and drop these activities. You have the designers, you set properties. It's a visual medium for creating the software flow, if conditions, exception handling. It then packages your process and publishes it to Orchestrator, from which robots can actually use it to run the automation, either when a user demands or in the background, which is the unattended automation scenario when robots run in a data center. Now, if you put all of this together, it looks kind of like this, but these are just squares, you know. So we have the robot running in the user session, so it runs, if it's a attended automation, that means that's a human user, and he invoked automation to help him solve a problem. So now I have the application in a certain state, and I would now have to do for the next 20 minutes, 24 clicks, copy and paste, which are always identical. So I just invoke my robot and tell him to run the process who does the 24 clicks, copies, and paste, and he does it in 20 seconds. That will run in the user session, right? And it loads the workflow, which has activities, which each one is a step. Activities interact with the target applications, which are being automated. And the driver component, which is our secret sauce, how do we automate all those targets more or less willing, it's what drives these activities, locates the widgets on the screen, does the clicks, get text, send text, so on and so forth. The robot service, it's daemon component, right? As they call it in Linux. So it's a Windows service which sits by and offers the robot, starts the executor when the process is launched, and can drive unattended automation. Unattended automation, it's a machine, a pizza box sitting in a rack, which can start Windows session and simulate a human user who does a process. This will be for machines who run contiguously, usually batch processing, queue based on demand, and they the automation there is generally so perfect they don't need human interaction and always have work to do. The tray agent is a little icon you get on your tray to launch processes in automated mode. And on the other side are the server components, right? The orchestrator. And it's a typical big web application. We use the .NET stack. It's fairly modern, as in we use pretty much the latest of everything, but we didn't yet convert to .NET Core. SQL Server as storage, Redis for cache when we have multiple nodes, Elastic for search and logging. And there is also another incarnation of all this, which is called the Cloud RPA, which is the big offering RPA as a service, right? In general, the orchestrator, we deploy it on-premise for people, but we're going heavily in the cloud too. So now, the real fun starts. Why it's so difficult to build software at scale? Because 40,000 robots later, at one customer, they started complaining and reporting us an incident on which the orchestrator nodes were reaching 500, were getting into a state on which we're serving 503 service unavailable. And the only way to recover was to do an Apple recycle, so restart the process. And we collected a dump and started analyzing. So when I say collected dump, started analyzing, I mean WinDBG, not Visual Studio, as the label says here. And so you have some very nice extensions. Of course, SOS is the most known, but Max, it's good. Well, NetX is awesome. NetX is debugging on steroids. And I'm going to show you some NetX commands, and you will have to agree with me. So mthreads is the first command we spent a week, more than a week, investigating this. It wasn't the first command we ran, but it's the first command I'm showing you. So the server was responding 503, service unavailable, right? So we look at the issue. We have the dump. We look at it. mthreads is going to dump you all the managed threads. It's a Max extension. So that's the output, right? And it's actually the output, the real output from the incident. So you see worker, idle. So that means it's a dump of a process doing nothing. We had, how many? 400 or something threads idle. There were 5-6 threads, which are the usual threads standing by, garbage collector, Quartz scheduler waiting for an event, Redis Stack Exchange client waiting for an event, so nothing. The server was literally doing nothing and responding with 503, I'm too busy, please go away. So then we took, there is a command wruntime and whttp, right? These, I think they also come from, no, these are nettext. They dump you the status of the HTTP pipeline. So the interesting number here is active request, 5,000, right? And that's the maximum number of, the maximum size of the HTTP pipeline out of the box. So the machine was responding 503 because the pipeline was full. And the 503 error, it's exactly what the spec says is going to happen if you have 5,000 requests in the pipeline. So we looked at it. So the thing is, if you have 500 HTTP requests and there are no threads, there must be somewhere. So I said it's a modern application. We're using state-of-the-art technologies on the .NET stack. So of course it's async await everything. And when everything is async await, if you look at the dump, well, there's pretty much nothing to see in it other than tasks, because everything is a task somewhere waiting to activate or being completed. And there is a big problem. It's called Causality Problem in analyzing await async situations, because you have no idea, there is no stack anywhere. There is a task, which is some object in the memory, and it's going to continue with this task, with this continuation, which is some other object somewhere on the heap, which is going to continue with this one, and so on and so forth. So it's awesome if you can figure it out how it all works, but as you see, we had basically 170,000 tasks to look at. And it was pretty hard to understand. There is this article on MSDN, I put here the list, it's called Async Programming, Async Causality Chain Tracking. And it's pretty interesting. It highlights this problem as in you can't figure out, it's not like old style programming with threads, because you can't really figure out what your calls are doing. We spent a lot of time on this. We learned a lot about how these extensions work and how to do debugging. And the best thing is nettext. That really came to save us, as in it was the only one who was up to the task. And because it has this syntax as W from, W select, it's like link over the dump. So nettext, when you load it, it's going to index your dump. It's a manage extension. So it can traverse the manage heap. It can index the manage heap. It's self-describing, because .NET objects are self-describing, and they're fairly easy to understand. It's not like native code. And you don't need the PDBs for that. And it's going to index everything. And then you can run like the first query I run there, it's show me everything which has a type which is similar to cache base, and display what type it is, the address, and the field in that type. So that _1_state, it's a field from, if you're familiar with how async await works, it's the state machine generated by the compiler for an await statement, right? So every time in your code you have function, async, task, foo, and in the function you have await bar. That's a state machine, right? And it's going to generate an object, put in the heap, which represents a state machine. And when the task is activated, it's a function which is generated by the compiler for you, who looks into this state. And it's going to look at the state of the state machine and jump in a switch case to continue the execution after the await. So everything looked like this. So there was this runtime caching cache base get async. So there were thousands upon thousands of state machines in this entry point. So that gave us the insights that what the task triage couldn't tell us is that the reason we have 5,000 threads, 5,000 HTTP request block is because they all reach this point and they are awaiting something. So when we looked at what was that point doing, it was not exactly this piece of code. It's very similar to this. So if you ever used Nito, any of you used Nito library, it's async locks. It gives you semantics because lock statement it's synchronous. So you shouldn't use it with async await, and I'm going to show you later why. So there was this construct in the cache. This is actually, it's open source, it's ABP cache, you can look at it. So it's get or default by key. If the item is null, so you didn't find it in the cache, then you're getting a lock in an async matter. So you're using await async lock, which is the title of my presentation. It wasn't an error. And if you obtain the lock, you try to get against the item, right? So there's a problem here, right? So using construct in C#, it's a way to guarantee that you call dispose on a disposable object. So obviously that async lock async statement is going to return a disposable object which represents the granting of the lock. When you dispose the object, you release the lock. And that's exactly how the Nito AsyncX library works. And they offered it to you in a very easy to read syntactic sugar using a wait async lock. So it's compact, readable. But there's a problem here. Because await, it's actually code. The compiler generates code for it. So using await async, it's exactly the same thing as saying using f async, f a function which processes the return of the async result. What if f throws? What if the await throws? Because it's the same thing. The code generated by await, can it throw? Well, nobody says no. And it does throw, and actually it throws on thread abort. And our friendly HTTP runtime and ASP.NET runtimes aborts threads with impunity. And so we opened that issue with Stephen Cleary, the author of Nito library, and we reported the issue. But the thing is this: I mean, if your syntax is using await of something, you're going to leak the lock. Because if it throws during the await, you lost the disposable object. Nobody's going to go dispose on it. And that object represents the lock. So then, if you have code in your server which has this point on which, in case of a Redis timeout, turns out that you evict the cache and everybody has to reacquire this authorization cache entry, everybody's going to block on this, waiting for the lock to be released. But the lock is going to be released when that disposable object is going to be called dispose on it, which nobody will. You could have made the object finalizer, well, that's what we told Stephen, but he didn't want to, and I understand what is not blaming him. The restriction of the finalizers are pretty bad. So in this case, that's what was happening. So we had these spikes, load spikes, on which the ASP.NET runtime would abort a thread. It will happen to abort the request as soon as it would start, and it will being blocked on this lock, it will almost guarantee to abort it when in the first code that run is that await code, the state machine generated by the compiler. So it will leak the lock. Now we have all the other lock waiters never waking up, and any new request coming up and piling up on that list and waiting for the lock. And slowly you would grow to 5,000, start throwing 503 errors, and never come back from this situation unless you recycle the process. So we fix the problem by basically getting rid of the lock in that code because it wasn't needed. It was part of the library we're using, but it wasn't needed. So it solved the problem. But about 2 weeks later, investigating another problem, I run into this random piece of code from a company called reference source Microsoft.com for the system threading semaphore slim, which had this interesting comment, as in, look, entering lock, waiter must not suffer thread abort. And they use this trick. They put the code in a finally, because a finally cannot be aborted. It's going to be aborted when you exit the finally. So in order to guarantee that between monitor enter, if lock taken and all that, there is no abort in the middle, they put in a finally. And we, of course, laughed and drank, and we were merry after the 2 weeks of burning hell for that investigation. And I throw a snippet out there saying that, hey, you shouldn't use lock with sync await programming. The reason is this. That's another dump we had about a year ago, more than a year ago. And that's another nice command, mthreads, I showed you the first time. But this is, look how the output looks like, right? So it's not idle, 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 idle. It's nlog targets, target, write async, thread safe. Nlog targets, target, write async, thread safe. They're all like this, and there were more than 400, I tell you. There are nearly 500 threads showing this. So that is write async. So all the functions in .NET will end with async. The convention is that they're async, right? They're async await. It's a function which has async await semantics. It's an awaitable function who takes a lock. So when you dump the locks in .NET, so there is this sync block command which shows you the status of the locks, right? Monitor held, there is incremented by 2 for every waiter, incremented by 1 by the owner. So 897, there are 448 waiters, 1 owner, and it's thread 594. So that's trivial to find. You go to thread 594 and you look, and he was happily owning the lock and writing into the database, which is a big anti-pattern. You don't go to the disk when you hold the lock. But that's how the library does. So you have this lock owner goes holding the lock, doing something, whatever, blocked on I/O, database call, and every other piece of async await wanting the lock. So async await blocks on the lock, it locks the thread. Your threads are coming from the thread pool. He's going to give you out all this thread, and you're going to see the thread pool going like this, and then like this, because the thread pool has a very funny algorithm of how he allocates the threads. And he's not going to be willing to allocate threads after a certain threshold, except, I think, 2 per second. And that's called thread pool starvation. Your process is blocked. And part of the things which are blocked are the completion of the thread who waits for the lock, because that also involves a sync await call, and that task who has completed and has to continue needs a thread, and the thread pool doesn't want to give a thread away. And you recycle the process. So never mix async await with locks. So as I said, 1 minute left, Q&A.
Just a question. You speak about the finally that release the lock. Usually the using statement in .NET, it's a syntactic sugar for try catch finally.
That's right.
And what happens when thread abort? Maybe the object is not constructed, that's
but
why...
the object, the using did not capture the object. Using object, it's fine. But using function, if the function throws, you never reach the using scope.
Okay, it was a function, not an object. Oh, okay.
Even if you say you have an object disposable, right? Var object equals something disposable. And then you say using f object, if f throws, the scope was not captured.
Thank you.
That's all? All right.
You're off the hook. Gotta work, man.
All right.